Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
Alrighty, let's take a look at our homework for lesson 7.1.1 and our M&Ms. I think we've got a little bit of data statistics happening in our M&Ms, which are not popping up into our lessons. So this makes me think that you must have been taught about histograms and stem and leaf plots in 6th grade, and this is kind of a review. We will be using these a little bit later on when we're doing a project. But let's just talk about what a histogram is. First off, a histogram is like a bar graph, but technically it's not. With bar graphs, you would have what we call categorical data along the bottom, like what's your favorite flavor of ice cream? And so we would have the different types of ice cream across the bottom, and then the frequency would still be like the number of people that chose vanilla or mint chocolate chip or whatever the different flavors are. With a histogram, this data across the x-axis is numerical. And so we still are dealing with frequencies, but it's along this spectrum here, which is numerical. So that's why there's no spaces between the bars in a histogram, is because it's got to include every single number that's on that number line. Whereas if it was flavors of ice cream and there were categories, you would leave a little space in between them. Okay, so sometimes students think, oh, a bar graph has spaces and the histogram doesn't. That's how you tell the difference between them. And while that's true, you can look at it and you can see that there's a reason for not having any spaces with a histogram. So in this particular one, it looks like the time it takes for students to get to school. And so you've got these things are called bin widths, and it looks like we're counting by 15-minute intervals. When we're working with histograms, you always want to make sure that the numerical interval is the same for every single one of these bins. Okay, so it looks like 12 students take between 0 and 15 minutes to get to school, 10 students between 15 and 30, and so on and so forth. Now, one thing to keep in mind, the number here, 15, if a student takes exactly 15 minutes to get to school, they're actually going to go into this bin, right? So if they spend 0 time going to school because they live right there, maybe it's like right across the street from the school, so literally takes no time to cross the street to get to school, then they would go in this bin right there. So anyone who falls on these numbers will automatically go into the next bin, okay? So that's how histograms work. You got your frequency here, you got your partition number of minutes in 15-minute partitions along the bottom, and then the bar just coincides, you know, however tall it needs to be for the frequency. Stem and leaf plots are different, okay? With the stem and leaf plots, you actually get to see all of the data items. It's just a different way of organizing things, and I actually kind of like setting things up. In the stem and leaf plot. Like for instance here, what do we have? Students in a math class receive the following scores on their tests. 49, 52, 54, 58, 61, 61, 67. So this is ordered data. The lowest was 49, the greatest was 83. So if you want to break them up into sections, it's like, okay, how many students scored in the 40 range? How many in the 50 range? How many in the 60? How many in the 70? How many in the 80? And you can just count these. It's like, okay, so you got your 52, your 54, your 58. Just a different way of setting this up. And one thing that I kind of like about this is that, let me do something along these lines. I'm going to do the fill color will look like that, and I'm going to make it so summary transparent. So here you've got, like, there's 1 there, right? And then here you've got 3, and then here you've got a 4. And so it kind of reminds me of a bar graph that's been tilted on its side, or a histogram that's been tilted on its side. Just my way of looking at it and thinking about it. It's just a different way of organizing all of that information. And you could still find your averages or your medians by doing the counting, knowing that this is in order, 49, 52, 54, 58, and so on and so forth. So some students like organizing it this way. Some people just like using the raw data like that. All right, let's take a look at our work today. It took Ivan 7.5 hours to drive 412.5 miles at a constant speed. So we know this is a distance kind of a problem where d equals rt, right? And so we have to declare or describe the distance and the time. It's the rate of speed we're trying to figure out. So we will divide 412.5 divided by 7.5, and that's going to give you 55 miles per hour is going to be the speed. Make a graph to show the relationship between distance and time for a bicycle that rides at 10 miles every hour. Okay, so here's the x-axis for time and the y-axis for the distance. And so the rate of speed is going to be like what we call the slope of the line. This point right there is where in 1 hour you've gone 10 miles. This point right there is where in 2 hours you've gone 20 miles. And this point right there is in 3 hours you've gone 30 miles. So the rate of speed, this actually is your unit rate in this particular situation, where it's 10 miles for every hour that you travel, right? 10 miles per hour. Remember the lesson that we said that this distance formula, d equals rt, is a proportional relationship. And so this graph shows that. If you spend no time traveling, you're not going anywhere. And then you're traveling at a constant rate of speed, so that's going to give you a straight line. So there's like a unit rate, and 0, 0 applies. All right, let's take a look. 25% of students at Marcus Garvey Middle School bring their lunches from home. 225 students do not. So how many students attend the school? All right, so we know this piece of information. We know that 225 people do not, and you either bring your food or you don't. And so this is telling us that this 225 students represents 75% of the people. So if you take this and you break it up into 3 equal parts, right, that would represent on the number line 75%, and then each one of those will be 25%, because 25, 50, 75. So you take that, divide it by 3, and you get 75. So that means that this is 75, this is 75, this is 75, and this is 75 for a grand total of 300 students. That's using the diagram. I find that to be a little bit confusing. I would prefer to do this. Part over the total equals percent out of 100. We know that, what do we know? So I guess we would have to, yeah, I guess we would be kind of doing the same thing. 25% of the students bring their lunches, which means the complement would be 75. So that means we know that this has to be with the 75. So that represents the part. 225 over x is going to be 75 over 100. So you can either look for a giant 1 here. What do you multiply times 75 to give you 225? Let's see what that does. 225 divided by 75 is 3. So our multiplier is a 3 there. You multiply 3 times 75 is 225. So 3 times 100 is going to be 300. And that's our final answer. All right, copy and rewrite each expression by combining like terms, make use of zeros, and using distributive property. All right, so this first one, I'm going to highlight all of my x terms, 4x, 2x, and 2x. All of them combined make 8x's. And then when you add the -3 and the +2 together, you get your -1. Here, oops, for this one, you got your -8x, which doesn't have any other x term to combine with. And then we add your 4 and your -3 together to give you +1. Here we've got 3 different variables. Not only do we have our x terms, we've got our constant terms, and we've got our x squared terms. So let's start with the x squared terms. 7 and 7 makes 14 x squared. 3 and 3 makes 6, and 4 and 4 makes 8. And then in this situation, we would send in the diag bombers, and that gives us 5x minus 4. There's nothing, no, 5x minus 20, because it's 5 times 4 is 20. 5 times x is 5x. So nothing to combine there. It's just using distributive property. All right. Sal can text 1,500 words per hour. He needs to text a message with 85 words. He only has 5 minutes to do this. Can he do it in 5 minutes? Well, I would change this to a number of words per minute. So 1,500 words in an hour is 1,500 words in 60 minutes. And when you take 1,500 divided by 60, that tells you the unit rate is 25 words per minute. So in 5 minutes, he would be able to text 125 words. So yes, he has enough time to complete this task, which I'm sure is extremely important. And by the way, who leaves class saying, I've got to text 85 words, but I only have whatever. Moving on. All right, find the new dimensions of the figure given at the right when it is enlarged by a scale factor of 2.5. Then find the perimeter and area of the original and the enlarged. All right, so scale factor is equal to 2.5, which means that every one of these side lengths you need to multiply times 2.5. So 4 times 2.5, 4 times 2.5 is going to be 10. So those two are now 10. 3 times 2.5 is 7.5, and 5 times 2.5 is 12.5. So if we are going to find the perimeter of the original, we're going to add 3, 5, 4, 4, and 4. This is 4 feet there. So it's 12, and 8 makes 20 for the perimeter. For the large, it's going to be 10, 10, and 10 makes 30. Right? 30, and then 12.5 and 7.5 is 20, so that's going to be a total of 50. So notice that when you take our perimeter and you multiply it times our scale factor, you get the perimeter of the larger shape. That totally makes sense. Now let's look at the areas. The area of the square, the smaller square, is, I'm going to do this in green, and then I'll do it in blue for the bigger one. 4 times 4 is going to be 16 square units. And this triangle right here has a height of 3 and a base of 4. So that's going to be 1/2 times 3 times 4 is going to be 1/2 times 12, and half of 12 is 6. So this is going to be 6. So 6 and 16 is 22 square feet. Now for the bigger. This is 10 times 10 is 100. And this is going to be 7.5 times 10 is going to be 70. No, that's not 75. That's a triangle. 1/2 times 10 times 7.5 is going to be half of 75, or 5 times 7.5 is, what is that, 37.5? This is going to be 137.5. Notice how this had a scale factor. You multiply that times 2.5, but this, you're going to multiply it times something else. Let's see. 137.5 divided by 22 is, this has a multiplier of 6.25. Interesting. So the scale factor for the perimeter was 2.5, but the scale factor for the area was actually 6.25. Something to think about as we move forward. And that is it. All right, let's go ahead and move on to the next activity. Take care. Bye.
Hey, feeling good, like I should. When in dark,